All right, we are moving on to projections. All right, so earlier we've talked about coordinate systems, specifically spherical coordinate systems, also known as geographic coordinate systems. Very important, very popular, used especially for data sets that represent the entire planet. Latitude and longitude are the geographic coordinates. However, most of the time we're doing research, we are working with projected coordinates. I'll talk about why in a second. But the idea is that these have an X and a Y. So instead of a lat and a long, they have an X and a Y, usually represented by an easting and a northing. So an easting is the X direction, northing is the Y direction. Now those are conventions. They're not always used, but probably over 90% of the time in the research world, that's what we're going to be doing. This is really important because we don't have a lot of spherical display devices. They do exist, by the way. Get on the web and look up spherical GIS display and you will see some, but they're incredibly expensive. Instead, we have flat display devices like paper and this screen that you're looking at. So we need to be able to project our data onto a flat surface. Okay, now, don't confuse these two. These are very important terms. Spherical coordinate system, again, that's geographic, lat long. Rectangular coordinate system is projected data, usually eastings and northings. Okay, you will also hear coordinate system and spatial reference system. I will typically use spatial reference system, but folks, especially Esri, switch back and forth and treat these as synonymous. They're not really, because coordinate system would be the most general, right? They could be a coordinate system for anything. And spatial reference system refers specifically to spatial coordinate systems, and specifically a spatial reference system, in other words, how we reference coordinates to space, usually on the Earth. All right. Also, projection is also misused quite a bit, especially by Esri. The project tool actually changes spatial reference system because it includes datum shifts. PRJ files, which a lot of folks refer to as a projection file, is actually an entire spatial reference, including the datum. So try not to get too confused with the terms. Okay, now to represent these two different systems, there is a geographic coordinate system and a projected coordinate system. This is what actually sits inside of a shapefile or a TIFF or another file to reference data to the Earth. It's somewhere associated with geospatial data, otherwise it's not referenced to the Earth. You might have already guessed, geographic coordinate systems are for geographic data or lat longs. Projected coordinate systems are for X and Y or eastings and northings. A geographic coordinate system is also known as a GCS. It includes a datum, which we just talked about. Really, that's the same as the ellipsoid, the shape of the Earth. Prime meridian, which is almost always Greenwich, England, and the units, which is always degrees. In other words, the thing we really care about in the datum is the ellipsoid, right? It's that NAD 27, NAD 83, WGS 84. And you'll see that the datums are labeled with the name of the ellipsoid for that reason. There are data sets out there with different prime meridians than Greenwich, England, but they're old. I haven't seen one in years. And because it's angular coordinates, they're always in degrees. Okay, moving on to projected coordinate system, the first thing it includes is a geographic coordinate system because we need that ellipsoid. Even though we're projected, we need to know what the original ellipsoid was for the data to properly place it on the Earth. We also need the prime meridians. The units, again, they're always degrees. However, added to a projected coordinate system is now a projection method. We'll talk more about those. And then parameters for that method. And then the units here are linear units, and they're important because they could be feet. In fact, they could be US or international feet. They could be meters. That's mostly what we see, but you can see other units as well. Okay, and these are again projected, so there's an X and Y, or an easting and a northing. And almost always north is represented as up, so it becomes Y, and X is horizontal, synonymous with easting, but again, not always. Okay, so for spatial references for analysis, these are things you want to know and remember. WGS 84 UTM Zone 10 North is preferred. That's the one I recommend folks use. NAD 83 UTM Zone 10 North, and we'll learn about what the projections are in more detail in just a bit. That one's almost the same, and you'll see it used a lot as well. Within agencies and a lot of the counties, they still use NAD27, and in fact, they use feet, where UTM is always in meters. But the California State Plane System is very popular still, probably will be for a long time, and it uses NAD27 and NAD83. We'll talk more about the projection part. Okay, definition of projecting. So projecting works with rectangular coordinates, also known as Cartesian coordinates. So instead of being in a sphere, it's in a two-dimensional plane. Again, we have y typically with north, x typically with east. And then what we're really doing is we're taking our ellipsoid and somehow we are projecting it onto a flat surface or a flat map. Okay? Somehow we have to get this sphere onto this flat surface. Now there are a lot of different ways to project the Earth. There's three main families of projections. Cylindrical is the one that I'm showing here, where you can think of it as wrapping a cylinder around the Earth and then stretching that cylinder out. Okay. Conic, putting a cone over the Earth and then flattening that cone. And then planar or azimuthal, where you put a plane on the Earth and then flatten the sphere onto that plane. Now notice these have three very different impacts on the data. And there's reasons to use different ones. A cylindrical projection typically work well at the equator. If you look at what's going on with the equator here, this stuff looks pretty normal. However, Antarctica has become gargantuan. Antarctica is not this big. So a cylindrical projection will typically maintain the way things are supposed to be, or minimize distortion, and distortion is an important word here, near the equator while exaggerating at the poles. A conic projection minimizes distortion in the mid-latitudes. Notice the United States here, Europe, they're looking pretty good, okay, because where the projection surface touches the Earth is where it's going to have the least distortion. So there you go. But the poles at both ends are radically distorted. Planar works well for the poles. And notice here, Greenland, Alaska, northern Russia, they look pretty good. But the US, these countries have just been, really, really poorly distorted. So the projection, the important thing to remember here is that the projection has to be selected based on where you want to minimize distortion and where you are okay with distortion. No matter what you do, when you project a sphere onto a flat surface, there will be distortion. The key is picking the right projection method to minimize the distortion. This is a video on a little tool, and I will actually show you that tool in just a second really briefly, but this tool goes into more detail. Now on top of those projection families, there's a bunch of other ones. I actually think projection is really cool. So I've played with them quite a bit. This one you may have seen on your high school or grammar school up on the wall. It's a very special one. And there's a whole bunch of other projection methods, and please go through this material in a little bit of detail and check it out, because there's a lot of great material on there. And I've got a bunch of additional resources at the bottom of a lot of these pages. Okay, so projected coordinate systems. Again, remember that a projected coordinate system has a geographic coordinate system, projection method, settings, and then linear units. And linear units can be different things. We'll talk a little bit about the methods, but the settings that can go with those methods might be things like the latitude and longitude of origin. In other words, a projection method can change where it starts, and then you can also apply a false easting or northing to shift where 0 is on the coordinate system. And then they work with linear units, and these are some examples.